Welcome everybody to DVT's Insight session today. We are very fortunate to have a return speaker in the way of Dael Williamson, CTO at Databricks EMEA. Dael is one of those people that we love having here to share insights in terms of what's really going on in the world. And today is no exception. More importantly, Dael's talking about something I'm rather passionate about, which is the human element in the business organization element that is being so impacted these days by AI and is absolutely critical to success with AI. On that note, I won't waste too much time other than to go, Dael, thank you so much for joining us today. Always look forward to these sessions with you and really appreciate you giving up the time today to be with us.
I'm really happy to be back, and it's always this is, I think, our third one.
It is, yeah.
Yeah, so very, very great to be here, and obviously very passionate about speaking to that part of the world. I had the fortune of actually being in Johannesburg at our AI days back in May, and did the keynote and had a lot of fun because it was in Melrose Arch, and I had all this nostalgia about like where I literally used to do karate down the road from that kind of area, and my parents lived there, so very cool. So yeah, lovely to spend the day with you and or a few hours or whatever.
Fantastic. And that just lets everybody know that Dael has very fierce and close ties back to South Africa. Although he brings with him a worldview and is these days tripping almost everywhere to share that knowledge with people. So we are absolutely fortunate to have him and have his time today.
Yeah, well, I'm looking forward to taking you through some thoughts, and I think this time I've actually counted for a little bit more you and us to have discussion time because I always love your questions. So I've got a presentation. I'll go through that probably about 30 minutes, and then you and I can have a little chat about like the ins and outs, and hopefully the audience can ask some questions. Do you
Fantastic.
want me to just get the show on the road?
I think so, Dael. For our audience, while Dael's bringing that up, the usual format is what Dael's just given you. He will talk through his topic for the next 35 to 40 minutes, and then we will do questions. If you have any questions that you would like me to pose to Dael, please do raise those either through the Q&A function or just drop them in the chat window. I'll pick those up there and moderate those and then present those through to Dael appropriate time. Dael, I'll hand it over to you.
Superb. So the talk, the thesis that I've been kind of building out for quite some time has been around the how AI is changing the dynamics of companies, and there's like quite a big amount of work that's going on there. So like Databricks, we see quite a lot of really cool stuff. I'm not going to talk that much about Databricks specifically. I'll kind of cover a little bit of why I'm able to draw out some of these insights. So this is not just observational stuff. There's actually some empirical grounding here. So this is built off a talk that I actually gave in Stockholm probably about 2 months ago, and I've given it like it iterates. So what's cool is we just had our summit 2 weeks ago in San Francisco. So like we're fresh, new product roadmap, new sort of launches and everything. So we call this the agentic tidal wave is here, but it's not here in a way that people are thinking in terms of hype. So hopefully this will give you a bit more of a sober view on things. So I always start with, yay, there's a lot of cool stuff going on. Actually, there is a lot of cool stuff going on. Stuff that like makes people quite surprised by how cool it really is. So, for example, if I go to this one over here, the single cell models to identify drug targets, turns out that you can take a transformer architecture and scale it up with RNA instead of scaling it up with language. And it scales the same way. So scaling laws still apply. So you can create like more and more data sets. And then what do you end up with? You end up with this very cool model that behaves like a diagnostic tool. And it's very, very good at identifying drug targets. So if you consider why that would be important, if you're designing drugs, That typically is like a 13-year horizon. Ironically, it's also a probabilistic engine. So one could argue, how do we give 13 years for ROI on a protein probabilistic engine, yet we're whinging about ROI on AI in 3 years? So don't get me started on that one. But what's very cool about this is it compresses that 13 years. It helps you to kind of get more accurate targets. It's very good at screening. It's very good at proving the diagnostics. Another really cool one is like 7-Eleven did some pretty cool things about store levels. They saved $300 million globally through just this one point solution. But if you look at it, these are all point solutions. They're very specific. They're very isolated. They're very middle to middle. None of them are very end to end. And that's where AI is today. It's making big impact in some places. It's making zero impact in more places, and it is not going end to end. So, quick thing about Databricks: we're like this incredible engine. We do enterprise intelligence. Actually, and lots of people don't realize this, we process all the agents and all the data like almost flows through us. So about 150 trillion tokens a month flows through Databricks. Okay. That is through all of the top AI companies. They actually use they use what we call Unity Catalog AI Gateway. And it's a router. So like Cursor uses it, Lovable uses it, like loads of companies around the world use this to process 150 trillion tokens a month. That's a pretty hefty volume, and it's going up all the time. We process about 50 million virtual machines a day. And that's on Amazon, Google, and Microsoft. And about 70% of the Fortune 500 are kind of using us to open their data and to basically accelerate their processing. So that's a lot of scale, but it's also a lot of empirical data. So we are the second biggest Databricks implementation in the world internally. We call our implementation of Databricks log food. And log food is all of these logs and telemetries that come from the tokens and come from the 50 million VMs a day. We can't see the inside of the data. We can't see what it is, but we can see what people are doing with it. So if you didn't live in South Africa, and you had an energy grid where you could actually draw insights from it. I learned this mistake the other day when I was trying to make a joke about energy grids, and I realized suddenly I was standing on stage in Johannesburg. But my energy company can tell me what time to run my washing machine, where I'm going to get the best bang for my buck to run that load. I can also be told what time to charge my electric vehicle. So that is basically what a grid can do based on the insights of usage. We have the same insights based on this usage. Okay, so why am I telling you all of this? Because that is an immense data set. And we have 22,000 customers. So I don't know if any of you ever watched the TV series House, but House hated talking to patients because they lied. He preferred empirical evidence. I'm very much the same. I like talking to our customers because they're very nice people. I like looking under the hood at the empirical usage data because it actually tells me what they're doing. And sometimes they use us in very surprising ways. This is one of the more surprising things that you'll discover. I've been flippant here. I'm saying about 100% of enterprises, probably more like 99%, because there might be some laggards out there that are just think AI is the devil. But about 100% of enterprises are all experimenting in some way. And what I mean by that is even if the CFO has a ChatGPT subscription and is just using it to ask questions, I consider that experimenting. About 10% of those are those use cases I showed you on the first slide. Okay, those are the ones that go to production. Okay, they actually have figured out how to test the thing, how to stabilize the thing, and they can actually go to production. 3% survive production. So the mortality rate is that these things, if it almost equates to like how venture funds will have a fund of 100 companies and 3 of them are winners. And if 3 of them are winners, the fund is actually successful. So the mortality rate is basically 3 in 100. It also turns out, and I did this analysis a couple of days ago, that the model attributes for $1, but the scaffolding and everything else, the data, the governance, all the other pieces are around $27. So for every $1 of AI model spend, you're looking at $27 of everything else. And ironically, we saw that before with machine learning. Machine learning was like this tiny thing surrounded by these many, many other things that made it work. So we're going through the same thing, which tells us that the importance of the model is diminishing. It's this incredible tool, but we need a lot of scaffolding to stabilize it. And the more we learn to stabilize it, the better. Okay. So anyway, let's go. I've done my own experimentation. So in the last few months, since the beginning of March, I have burned 43.1 billion tokens. This is actually from the 1st of March until the 8th of June. I ran an experiment, like a time-boxed experiment. Now, what's cool about that is that's about 640 hours of business time, and I did 9,195 hours of work. So, one would say if I get paid X amount per year, and that specific time period that I was getting paid for was 640 hours. And then I actually added an extra 9,195 hours of work to that. And the attributed cost, it says there like 95, that would be retail cost. That would be like if I were to pay Anthropic for this time, would be about $35,250. Okay. But if you cache a large proportion of the trace and telemetry and prompts, which is about 87% that we are able to get to, you can limit that to the total cost that we actually had to pay out was about 13% of 35,000. So you can actually minimize the cost dramatically. I have 9 non-humans that work for me, and they have an average of 8.4 agents each. That actually, the agent number's gone up because I've been working on this like recursive self-improvement thing, where my agents are getting better because they're idiots, to be honest. When they start, they're pretty stupid. They can do some things quite well, but you have to really work with them. And I think that this is why the ROI equation is completely flawed. Like, I think we're looking at the wrong thing. We're very, very specific on productivity, but we're not looking at capability expansion. So like, how much work can I do? So let me draw a comparison. Because of my role, I travel a lot, and you can't really code traditional style if you're always on a plane. And I mean, now even with Starlink, it's still pretty tricky. You can't you can't be coding if you're always getting bounced off the VPN on your hotel Wi-Fi, or you're in an Uber and you're roaming. Like, these things are just far more challenging. Well, it turns out that you can do these things a little easier when you have a fleet of agents coding for you. So I've gone from like, quarterly bursts of maybe a week or two where I get to actually dig into the tech and play around, and I love coding, to now continuously doing it every day. Because as you can imagine, 9,195 hours is quite a lot of sort of AI vampirism. The other thing that I love to do is I love to use an analogy at this point. So there's a lot of people in the world that talk about AI. How many people get this joke? So if you don't get this joke, you are not a parent of AI. Now, the joke is, okay, you have to kind of make your machines work, and they have to stay open if you're using a normal harness. Otherwise, they stop working and they just basically cease and desist. My joke about being a parent is Michael McIntyre is a comedian out here. What he says is you can tell people that are parents and people who are non-parents. People who are non-parents don't know how hard it is to leave the house. I see the same thing now when I listen to people talk about AI. I know from what they say and their tone that they are not parents. They don't know how hard it is to leave the house. They don't know how hard it is to build with this stuff. They don't know how annoying it is when you have to close your laptop because there's a flight attendant who's whinging at you. You can use your phone, but you can't use your laptop. So you've got to put your laptop away. But I've now got to stick my finger in my laptop, which I've put into the sort of front pocket of the desk. And anyway, it's so moral of the story here, anyone who's not playing is not an AI leader. You have to play with this stuff. It is unruly. It is basically like looking after children. What's very, very cool when you start to play, I have the fortune of having started my career in 1996 in Cape Town at one of the insurance companies out there, building a mainframe for an underwriting system. I wasn't building it. I was actually building a new product line within it, because if I'd built it, I'd probably about like 40 years older. But during the time period of building this, we went through a movement which was called the Unix movement. The Unix movement was moving away from the monolithic mainframe into these file systems, and Unix and LAMP stacks emerged off it. And they actually had these primitives. One was the shell, the things you wrote, shell script, all of that sort of thing. File system was basically how you stored stuff. Markdown was how you wrote stuff out. And cron jobs were how you got repeatable schedules. If you add an LLM to that, okay, we effectively get an agent. And this is basically what Mark Andreessen called out. And this has been the movement. I have written a ton of shell over the last sort of 6 or 7 months. It's crazy how much shell script I've written. But I haven't written it. It's crazy how many markdown files I have. I haven't written them. I actually orchestrate them. So my job has changed, and the whole thing has changed. So what have I learned? So I've learned that software has become a commodity. I call it the Temu of software. It's fast fashion. It's super fast. You can build software incredibly quickly. But it misses something. So we used to give valuation of software 5x. 5x was the valuation. If you created a SaaS company and you were a SaaS founder, you created a software company, and if you did really well, which was like quite often, you would be able to collect 95% gross margins, and you would have a business that had a high valuation, probably more than 5x if you did really well. And you would basically be able to sit fat and happy, and there was a playbook. All of that just crumbled away at the beginning of this year. So I've learned that it is actually more valuable to have really good test harnesses. And when I talk about test harnesses, I've had to invent new forms of testing. I'm constantly researching who is building new tests, because the tests we used to have, unit tests, regression tests, CI/CD, do not work for this type of software. The drift is far too fast. Like the everything moves. It's like building on water. So I have 10,000 tests that I run just to avoid the amount of judgment overload, the cognitive load. I'm exhausted, to be honest. And one of the things I'm trying to do right now is biohack myself to kind of get out of exhaustion, because human brains can only process 60 bits per second. And like these AIs are hitting us with large avalanche of information. The second thing I've learned is telemetry and trace is super important. I process everything. All the session trace, all the prompts that I create, everything. I use that. I have a database that basically I build up of trace and telemetry. And I use that for recursive self-improvement of my agents. I build them better. I make them better. I improve them over time. I'm not talking about dumb Ralph loops. I'm talking about recursive self-improvement, what Karpathy went to Anthropic to do. And you need that kind of trace material. And it turns out that actually that's an incredible way of getting frontier models. So like at the beginning of this year, Cursor did this with their Quinn model, with the Quinn Chinese model. They basically used all the trace and telemetry, and they shot their new fine-tuned model, which is $14 cheaper for 100,000 token output than Anthropic, and it went straight to the front of the leaderboard for coding. They've done that a few times with Kimi K2 and a couple of other Chinese models. So Chinese models and trace and telemetry is a massive new area. that people should be experimenting with. And I think this is one of the biggest opportunities for the South African market because we're very good at frugal software engineering. Take some Chinese models, benefit of being part of BRICS, and create some fundamentally awesome IP because you can't store spyware in a neural network. So you can unpackage and you can start to run some of these open source models. You can source the open source models from NVIDIA if you diametrically opposed to using models from certain countries. But it doesn't matter. It's the OSS model movement, and they're brilliant, especially when you do fine tuning and you use the trace and telemetry of your proprietary data. And then the third thing that we're starting to see emerge is this open orchestration. You need to own your orchestration layer. And your orchestration layer is going to be your new IDE. And I think there's going to be one that emerges for every domain in the enterprise. We're seeing them for coding already, but we're going to start to see them emerge for all sorts of other areas. Okay, so let's talk about some stuff that's changed. So what's changed? Before 2024, a developer would write code. Okay, after 2025, 46% of GitHub commits is done by AI-generated code. The new bottleneck is pull requests. So even Databricks has a team of 2,000 engineers that build the platform. We have a number of product managers, like probably about 200, and their job of building out the PRDs, so the product requirement document, has shrunk from months to weeks. The job of building has shifted to iterations of sprints, as opposed to 2 years to build something, or maybe 6 months to build something. So the compression of time on the software development lifecycle has totally changed. Product is faster. Engineering is faster. Pull requests reviewing is slower. So QA is now one of the biggest bottlenecks we have. And we're seeing this everywhere. A fun fact, GitHub seems to go down every Saturday afternoon here in the UK. So one could argue it's like the West Coast of the United States coming online, and the scale is killing everyone. So GitHub is actually facing all sorts of issues. There's so much craziness going on in the infrastructure layer. So loads of people are trying to figure out, what do we need? What tools do we need? Now, we've been here before. We were here in the 90s and the 2000s when we started. When I started my career, we didn't have Git. We didn't even have SVN. We had to build repos. We had to invent CI/CD. We had to invent DevOps. It took us 15 years to do that. So that's a whole cycle of work that's going to take place a second time, but it has to happen for this new way of sort of coding. If we then go to security, similar things are happening. We used to have in SOC triage, every alert would have to be looked at by a human. Now agents are looking at thousands of alerts per hour, and they send the response, the escalations, to a human to review. Same thing happens in radiography. It has been happening for years. A radiographer will look at only the exception x-rays, not at all of the x-rays. Okay. If we look at risk management, before 2024, an army of 2,000 engineers that were outsourced and offshored would have to build all of these millions of data sort of processing things and start to build Monte Carlo simulations that you could run maybe twice a year. Well, it turns out that after 2025, what happens in risk management is that you can build these simulations with small teams and do an exceptional amount of stress models per week. JPMC is running hundreds of stress models per week. So your argument back to me is going to be JPMC have a lot of money. So how much does it cost to run a stress simulation? So we tried this out. Last summer, we actually did this. So I'd remiss to say it'd probably be better today. We applied it to supply chains for weird reasons. Europe was facing a whole lot of supply chain problems. We don't know why. Last summer, it was a very strange thing. We actually are facing them again. And we took a bunch of maths from MIT and with 3 engineers in 20 hours, we built a stress testing supply chain network where we could run a complex simulation in 38 minutes for $1. Okay. And that is AI coding to build mathematical models, not AI models, mathematical models. And this works on all three hyperscalers. This link actually takes you to where the GitHub repo is because we open sourced this code. We then took some agents and we went, all right, well, supply chain managers typically don't really know how to read this complex mathematics and interpret it. So we built a series of 5 agents that started to inspect and review and explain the maths, and they could basically direct what could happen. What we'd effectively done with 2 engineers in 8 hours is built a new form of application engineering. There's a data layer, there's a mathematical simulation layer, and there's a reasoning layer that sits on top. That is 3-tier architecture that is fundamentally different from anything we've built before. We then decided to stabilize it because everyone kept saying, well, you can't just move these things around because we have contracts with these customers. So we just shoved the contracts in the database because it turns out you don't actually need them to sit in SharePoint anymore or your file server. You can put them into a vectorized search. And actually that even is changing where you can now put them into Postgres. So our AI search now goes straight into our lake base, which is basically a decoupled Postgres service. And we could put supplier contracts in there, and we could put purchase orders in there, and we can actually use that to stabilize the decisions and rationalize the advice we give to supply chain managers. This 2 engineers, 15 hours. So what I've shown you is a multi-sprint that where we've built stuff that didn't exist before. Now we have to test it, stabilize it, and actually build the telemetry to manage it. That's the hard bit. The easy bit was actually getting stuff that no one could build in the past. Right, so obviously I work with lots of companies around the world, and we see the failure modes. So let me talk about the failure modes quickly. So the first problem is models are smart, and they don't understand your company. They don't get your company. They actually can give you really good advice about a bunch of things. They do not understand how your company works. They don't know your language that you speak in your company. They don't understand how you interoperably move things around the world. They don't understand how you measure things. They don't understand how your people work. They don't understand how you're organized. The second problem is your software stack was built for humans. It wasn't built for agents. It's got beautiful user interfaces, and sometimes it's got really shoddy, acceptable user interfaces, but agents hate those. So to a human, a user interface that is non-performant means a sip of coffee. To an agent, it means token burn loops and a lot of additional expense where you can end up paying $5 just to look up a Slack message or a Teams message. Maybe that's $10. The third problem is there are lots of silos in companies, and that basically makes it very difficult for AI to do its work. The fourth problem is people basically make or break the AI transformation. This is one of the most fundamentally fascinating areas. The fifth one is governance and security. The way we do it today, the administrative way we do governance and security today, slows you down. It is the bottleneck. It is a massive bottleneck if it's done in the old way. Right. So I'll double click on each one. So the first one, AI without data is just hallucination. So models need to understand your data. They need to be able to go through one unified pane of glass and look at transactional data. They need to look at all of the unstructured data that's put in a vectorized way and embedded. They need to be able to do time series simulations. Okay. Did you know there's 434 databases on the planet today? So in order to pull this off, if you have the spread of databases everywhere, there's actually a ranking called DB Engines. DB Engines ranking shows you that there's 434 databases that exist in the world today. Now, that's a lot of copying and pasting that you have to do between data to data. So for a human, that's called ETL, and effectively means there's a lot of moving and integrity checks and taxes and things that you have to pay. For an agent, while it's very fast at doing this, it's basically token burn. And token burn is money. So the more you have to token burn to copy things back and forth, the worse. Now imagine you could go through a single pane of glass and you could start to create these telemetry loops. So your agents basically become increasingly performant over time, and you own the IP. You own the data, you own the models, you own the IP. Imagine that world. That is a world that is very realizable. Because one of the biggest problems is if you just bank everything into one of the foundation model companies, you are the product. Let's talk about the design surfaces. So for many years, software companies have designed for humans. We do UIs, we do usability testing, we make pretty little psychological profiles of people. I remember working with Expedia many years ago where they got a team of 100 people to use the front end to book travel. And they took video analysis, and a bunch of data scientists analyzed their micro expressions so that they could optimize that beautiful customer journey. Agents don't care. Agents want to just get all the context so they can move on to the next job. So the problem with a UI, as beautiful as it might be, is it's what is referred to as lossy. Lossy means you've basically removed a whole lot of the context. It's a bit like taking a PNG file, which is high fidelity, super high pixels, and making it a JPEG because you want the file to be smaller. For an agent, it likes the depth. It doesn't like the small. For a human, we can't really tell the difference. So we need to design two surfaces. We can't just design one. We can't just do a hard pivot. Now, it turns out actually that 6% of Databricks usage is humans still writing code. This is not the same number that existed about 6 months ago. So agents have overtaken human usage on our own platform. We're also incredibly lucky because we designed for APIs and CLIs because we had a lot of third-party developer tools like VS Code and GitHub that used to plug into Databricks. In order for people to use the IDE. That actually has turned out to be a very lucky thing because now agents can use the same interfaces to access Databricks. So these are things that need to happen to your software in your company. And if you don't have it, you're going to have huge token builds. The third thing is the process illusion. So there's this paper that was put out last year called the garbage can versus the bitter lesson. Now, management tends to think that a process is 6 stages. What they don't realize is under the hood, there's like thousands of activities that take place to form the 6 stages, to move work from A to B. In physics, we call that activation energy. And there's a huge amount of activation energy that takes place to move from stage to stage to stage. The garbage can theory is basically like the fact that 80% of that, squiggly line at the bottom is garbage. It's power, it's politics, it's resource hoarding, it's, just trying to get into somebody's calendar. Now, if humans do it, we have a high tolerance for people just kind of doing work. When you have to pay an AI company for a token burn, for it to go in that messy loop, you end up with big problems. Now, the AlphaZero lesson is actually quite fascinating. DeepMind wins the world Go champion with AlphaGo, trained on 2,000 years of Go knowledge. AlphaZero learns how to play the game of Go through self-play and crushes AlphaGo. That is the bitter lesson that Richard Sutton wrote about in 2019, where these things are actually better at process design than we are, so if we let them. So we have to drop our egos and kind of just reimagine process, but reimagine it through an AI agent, not through a workshop where we debate words for 2 hours. Another one that's very fascinating is organizational structures. We tend to think in hierarchies, and we build these org charts. Okay, agents, for humans, those org charts are coordination overhead. Like we feel it every day, but we accept it. For an agent, it's token burning loops. Agents actually prefer to work in networks. So as I've been building my little fleet of agents, what I've discovered is they love networks. They love to operate in networks. They love to, the collective noun is called a swarm. So they love to operate in swarms. Now, the funny thing is, when you look at a flock of birds that are flying, you don't need, every bird tells the next bird where it's going, and birds don't crash. So they are incredibly good at figuring out how to move in a wonderful sequence. And watching birds is one of the most beautiful things to do. But watching agents, when you can get that flow and that kind of network swarming happen, is quite remarkable. It's very taxing on the brain, though. So you've got to figure out, one of the things we have to figure out is the interface between humans and swarms of agents, because remember what I said about the 60 bits per second. Like, AI burnout is a real big thing. I'm very tired right now. Right, governance. Our empirical data shows us that strong governance that is codified makes your AI go to production 12 times faster on adoption. Okay, now what does that mean? That means you actually have to think about governance more end to end. You have to think about governance of unstructured data. You have to think about governance of all of your data assets. You have to think about governance of all of your models. You have to think about routing. You have to think about discovery. You have to think about the mapping that you make to allow people to find things. Quality control is the new bottleneck. Legacy is your biggest inertia right now. Like, try as you might, slapping an MCP server on top of anything is not going to get you like through the legacy inertia. There is going to be a replacement cost. So it's either the cost of having agents do work, hammering something, or it's the cost of replatforming. And the replatforming probably gives you a huge upside. We're also learning on the economics of software that like the return of build is happening. When I started my career, every enterprise had a building programming team. For many years, we offshored and outsourced that. So we've forgotten how to build. The average enterprise doesn't build their own software. They outsource, and they're basically glorified procurement officers. Like, we need to learn to build again. And the cool lesson that I can give you is that you don't need big teams anymore. You saw what I could do on supply chains with a small team of 3 people. I've seen the same thing play out all over the world. People have built the most remarkable software with small teams. We do, though, have to think about how we manage that software. So what happens to that software once it's in production? It doesn't look like IT services management anymore. It looks more like flight traffic control. We have to think about the flight paths of agents. We have to trace them. We have to improve them. And they drift very quickly. So we have to monitor them immensely. So that's going to lead to a massive new avalanche of new work. Basically, this nonsense that, this is going to take jobs is nonsense. Right, so quickly, like successful enterprises. So we know that like many enterprises are failing. We also know that there's a confidence gap on these things staying in production. We know there's a communication barrier that takes place. So what organizations are doing more and more is they're using agents to map their org, build digital twins of your organization. They're using this to work out optimization strategies. How do I get rid of that stringy ball? We work with a company called Celonis that is based in Germany. They're a decacorn, and they basically mine your processes and surface that spaghetti ball diagram of garbage can. This is what your actual process looks like, and you can then start to simulate what that could change to, which will give you a much faster flow when it comes to like how you build your agentic org. Data is an intellectual property. You have to guard it. Images are data. Video is data. All your file servers and all of your communication data that you have in your email and like your Slack and Teams messages are some of the most valuable data on the planet. And then I think we're going to reorganize teams completely. Like all the boundaries are collapsing. In our product and engineering org, those boundaries are completely collapsing. We're seeing the same thing collapse in other domains within our organization. There aren't like specific roles are just moving and melding between other roles. It's basically like role soup. but it'll happen for a while and then new roles will emerge. So you will start to find, I have a hypothesis that everyone will be a software engineer. Software engineering will diffuse through the entire organization because now it's so accessible and it's so easy to build software to help you do your job. There's another very fascinating thing that basically buy and build is going to become the huge new inflection point at board level. So if you are someone who buys AI, you don't have an AI strategy. Building AI and not doing it through bare bones, I'm going to train my own models, I'm going to basically build my own scaffolding, all of that, that's not going to work. But you have to play with the stuff to understand what it can do. It's very different to anything we've worked with before in our lives. There's a whole big movement of different tools that you can build on like a stable database. One of the things about Databricks is we see ourselves as the AI database because all of these companies that are emerging build with us as the back end and they use us to create new kind of ways of working. Cursor obviously targeting specific coders, Replit doing the same thing. Posit is more scientists. Lovable is targeting everyday users. Everybody is going to need a log food. You have to have this logging and telemetry. This is the most valuable data you have. You have to have it in an open format. It is basically got to follow the same thing as a lake. What's ironic about it is it's very similar to IoT. The first use case will be predictive maintenance. The second use case will be anomaly detection, but it'll be of your agents, not of your IoT things. Build and buy is fundamentally going to change. We're moving from the record layer to the engagement layer to the work layer. The new IP is where all your business logic is. This is an opportunity to unlock it and protect it and build basically a new way in which you run your business. And you need your data to basically be free and open. And you need to think about what the new UX is going to look like. How many people enjoy going to many, many different applications to do their job? The context switching is horrible. It's already hard enough just to deal with agents every day. Now you have to also deal with many interfaces. It's massively exhausting. So I'm going to leave you with these lessons that we've learned. I work with a lot of B2B software companies, ones that are surviving SaaSmageddon because they're established, a lot of them being bought by private equity firms. I'm working with a lot that are new startups that are emerging. They're doing some of the most fascinating build work. Some of the things they're building will blow your minds. It's very early, but these are the things that they're building towards. They keep lock-in to a minimum. They want to keep their IP intact. This is actually coming from buyers down. New enterprise procurement teams are using these 5 things to decide whether to buy software. Does the software comply with these 5 things? Is it portable between clouds? I might fall out with cloud A and want to move to cloud B. Is it glassbox so that I can explain the results? Explainability is still massive. Transparency is still massive. AI regulations coming. Headless. Can it work behind an interface I've designed? Is it footless? Can it move data back and forth? Is the data accessible? Is the context accessible? And that's the wave.
Dael, at the end of your talks, I'm always kind of left going, I probably need half an hour to recover, just so that I kind of find my feet again from a mental point of view. And you kind of referenced the brain's processing at 60 bits per second. That's probably you, my friend. The rest of us, after your conversations, kind of go, I thought I was maybe at 50. I'm back to 10. But that's part of the excitement of kind of going, all right, there's some catch to do here in terms of understanding and getting back into these elements. I think the first thing that occurred to me to ask you is going, in these dynamics of all this change that's taking place, there's a fundamental switch here in terms of how solutions are being built, where they're being built, how they should be built, and how you should approach it from a solutions point of view as a person involved in the space. And I think others on this call probably feeling like me. It's like, to be successful in this space, I need to be a Dael. I need to be someone like Dael that's seeing it the way he's seeing it and progressing with it. So I'm going to ask you a very unfair question to begin with. How do the rest of us become more Dael-like in this area?
I mean, it's a kind thing you say. Um, I'm a scientist, and one of the things about science you learn is the scientific method, the curiosity of discovery. Um, and I have an unfair advantage that I spent 15 years in that realm. When I did my undergrad at WITS in science, um, I wouldn't have classified myself as a scientist. I just learned a whole lot of the theory. When I went into honors and masters and did actual research and actual applied research, that's when I learned. I think everybody needs to kind of just apply and play and be curious and try stuff. One of the coolest things you can do, I mean, I had like we've got a sales guy in our team that basically started using Cursor and vibe coded himself a CRM just to see if he could, right? We've got about 1,000 CRMs that have been vibe coded. They're all rubbish, but you know, they've all been built. So people need to play, people need to do these things. Now, obviously, there's a cost. Like the taps have changed in terms of all you can eat token use, but you can also do a hell of a lot on a Mac Mini with some open harnesses and some cheap models. You know, you don't have to actually do that. And actually, I think that would be the better design principle. So the first thing is be curious, you know, just play, learn how the stuff works. Um, just try it on the weekend. You know, you have to learn how to become a parent of these AIs. The second piece of information is like you can't throw the baby out with the bathwater. I'm finding myself going back to so much theory from the 90s, theory from the 70s, we've been through these shifts before, and there's so much incredible grounded thinking. Like the idea that people are building software that looks like SOA, that looks like domain-driven design, that looks like object-oriented design. There's a huge amount of that theory that is now just approachable in a different way. Um, Business process modeling. Like I spent about 3 weeks just investigating like the anatomy of like a skill that somebody would build for AI to use. And I used a combination of business process modeling and RESTful design with Solid to actually start my like, how would I build a skill? And I came up with things that can run long range jobs. So I was using a lot of research from the past mixed with stuff that I'm experimenting with the future, and a little bit of grit to kind of make it work. I think you also have to challenge the memes. Like we have these like preconditions that this role does this job. Does it? Why? Um, things work in this way. Really? Why? And I think we go back to lean. So one of the coolest things about flow and lean thinking is you optimize things to move in a very coherent way. I think there's some very, very small fundamentals. It's curiosity, so play a lot, um, you know, just break the old memes, challenge a lot, first principles, and use a lot of the collective wisdom of the past. Those are just very, very practical ways of kind of cracking on. One of the things in South Africa is, you know, the community out there, they're hard workers, and they do tend to challenge because you do have constraints that some of us in the Western world here take for granted, like, you know, abundant energy, like the lights will switch on when I get home, you know, simple things. But that frugality is actually an advantage because some of the best tech in the world comes out of that part of the world. And there's a huge amount of tech entrepreneurs that have come out of that part of the world. So just lean into that stuff. I think this is one of the best times in the world for the Africa builder culture to kick in.
I think around that, it winds up being a case of recognizing just how different it can be now.
Mm.
And yes, there are methodologies and frameworks from the past that people need to probably refresh themselves on. I remember sitting in a data analytics event in Dubai, and folks were asking the question, well, how are we going to approach this? They're going, how's this any different from taking Six Sigma DMAIC in terms of a process? And you're simply applying AI at a point here to kind of go, it's going to do certain things. That obviously gets taken to a different level where you're going, hey, the agents are better at defining this process than you are. So, okay. But I think for the understanding and the different role that the humans play in the solutioning now still requires that those frameworks and references and pieces that you can decompose into manageable bits so that the 10 bits and the 60 bits per second actually understand what they're meant to do, when they're meant to do it, and what they can ask for. And it starts to fit with other things that we've seen in the past. I think it was Gartner that pushed out the multi-speed IT functions, right? So you have a certain bit that's iterating and doing fast bits of innovation, and then you hand that off into another space. And I kind of look at it and go, well, aren't we just in the same space, but we're the slowest strip in terms of what we do, and we can have this whole agentic bench that's doing stuff for us. And when it throws something back at us, have a
I,
way of dealing with it.
I think you're on, I mean, that was the whole bimodal IT thing. I
Mm.
remember that. I was like, I actually always believed it was multimodal. I thought like this idea of two things is just rubbish. Um, but I think now there's this very slow legacy lane. There's the us lane, who are now the second slow legacy lane. And now there's this high throughput, massively fast, but they make a lot of mistakes. And, like without proper guidance and judgment and sort of figuring out accountability, like, we've never really solved, like somebody actually said, how do you make the agents accountable? I was like, well, shouldn't we solve making the humans accountable first? Um, we we actually can re-examine a lot of management frameworks. We can examine a lot of ways in which we conduct work. Um, Nowadays, there's a huge amount of meeting like culture. Like, how do you change those things? I think this is just one of those moments in time where we don't throw the baby out with the bathwater, but we can throw 80% of the garbage out. Um, and the cool thing about that is like it just means critical eye to like what is the garbage. Um, there's a lot of ego that is going to get ruffled here, and there's a lot of tired people who are going to be pushed. They've just gone through, they're at the end of the digital revolution. Oh, I've digitized my company, and now we're going, okay, well now you've got to gentrify your company. Like, it's exhausting, kind of these shifts, that the constant change. I think there's people who naturally just want to stop and like, you know what, I've just done the SAP rollout to this thing, and now I just need to stop for a while. I don't think that's the right advice, but you do have to operate in different speeds, and maybe that's how you organize differently. Maybe you have different kind of speed teams. Maybe there's different resonances that happen. Like, we're kind of learning these things, and we're figuring these things out as we go. And there's lots of existential questions that creep in. It's coming from business schools, it's coming from everywhere. Um,
Yeah,
it's just system thinking.
it is. And I think for lots of those organizations and the executive teams and business folks that are in there, they're all kind of going, where am I going to find this value now? And to your point, the organizations that are jumping to that realization that the way it should be done or the way it can be done is fundamentally different to how you did in the past. And it's not necessarily following this ordered step change between where you are today and then there's this progressive piece here and then you do this and it's a nice evolution towards it. No, if you want to actually realize the full benefit of this, if you want to realize a clean way of getting to where value will be realized in terms of how your processes and organization run and how people function within that space, it's a big jump off the cliff. and kind of going, there are aspects of your parachute that exist, and you need to be building those very quickly in order to land safely on the other side of this. Is that something that you're seeing in that differentiation between the current winners in the space versus those that are still fumbling?
I don't think there's many winners in the space yet. Like, we're still learning, and that's why nobody's late. You have to be a bit bold though. Like, there are ways to do specific, like that. Every single one of those point use cases that I had on that initial chart are massive ROI, huge big wins, but they also are massive examples of widespread inefficiency. Like, things that we had done in such a very, like, it was almost like I've got two young kids, and there's a TV program called Zootopia, and like they go to the DMV, which is basically the equivalent of one of the government organizations that gives you your driver's license. And there's a sloth that's sitting behind the thing going slowly, kind of stamping the driver's license. And I watch some of the functions within organizations that have worked in the same way for so long. And there's like this, it will never be another way. It can only be this way. And like, those are the ones that are the point use cases that really fun. They're like a total step change. Like, legal AI is probably one of the biggest winners. Like, it's crazy how that is one of the biggest sort of domains that it's growing. You've got AI companies entering that space left, right, and center. Legal is arguably one of the most underserved domains in tech ever. Construction and engineering, another big area, like very limited tech, huge appetite to adopt AI. And it's because basically they're going from like paper and maybe some emails and Word documents to this new paradigm. So the step change is jumping through, like they're literally jumping from like something that most organizations were using in before the 90s to like 2026. But the cool thing is they can kind of make these big jumps. Like, we need to learn how to use this technology. We're like basically similar to when we were in the 90s. We're at like kind of waterfall AI. And there's a whole lot of stuff we need to invent. The more people that are doing it, playing with it, learning it, the more we learn, the more we do, the more we do, the more we learn, the more we learn, the more and you've got to just get into these recursive loops. It's fun, actually. Take breaks though, because glutathione reduction and all sorts of weird pathways in your brain start to get messed with.
Well, you're not going to get to 90 bits processing without doing some of that stuff. So there's
Oh
some
yeah,
burn to do, and you'll be okay.
yeah. No, but look, I think this is just the best time for everybody to just play with stuff. I think it's also like there's we can challenge a lot of assumptions. I don't think that this is going to move as fast as everyone's touting, but I do think that if you're not playing with it, learning it, experimenting with it, and I'm not talking about chatbots. Please stop playing with chatbots. I still use chatbots. Okay.
One prompt.
But I do a lot more kind of things nowadays, and it's encouraging and it's fun and it's frustrating, and it's like it's parenting. It's very crazy.
So I think within the messaging today, there's been that piece of advice from Dael already, which is become a parent. You'll be a better solution developer, both through the fact that you understand how to work with kids, agents, and second of all, you'll be watching enough Disney movies that you'll actually realize just how educational those things really are.
Oh yeah.
Dale, there's probably just one other thing I'd pick on. And again, I've been terrible to our audience of going, hey, ask questions. And then I just ask my questions. I apologize to everyone that attends these sessions basis. But I did want to ask you about this specifically. Within what you've covered today, you kind of went build on an intelligence platform. And I'm leaving off the data word because I think internally I'm responsible for what we do in data platform, but I think along the way I've realized data platform has become something else. It's become solutions platform because it's connected into all the aspects that are so critical now to how you go about doing things in the new way. Semantic engineering is there to give context and understanding, particularly to agents, enormously valuable. The GRC stuff is there through aspects like Unity Catalog and other mechanisms that are there to bring this governance and control across what you're doing across the platform. The platforms have originated their way of work through data. How do I bring it in? How do I ingest it? How do I have structured, unstructured, everything there to work with in the first place? And then across that, how do I build models? And now these days, how do I build agents? And how do I connect to LLMs and generate code? So there is a single place now where all of this new capability is brought together in a way that allows you to do solutioning in the new way. So is this something that organizations now need to be looking at differently to kind of go, that is my world now? And in addition, if I pick the right place to be doing these things in, I benefit from the scale of what's being built out there on the similar platforms where all this data and log food is being generated. And that just takes me that far forward compared to anywhere else that I might be doing these things.
Let me put it this way. We used to have a team over there that were building software for finance and a team over there that were building software for HR. And it wasn't just one piece of software. It was like many bits of things glued together and wired together. And then you would pull data out of it, move it to a sort of separate place, organize it, and shove a report back. And that was basically the linear progression of origin to analyze. There's this long chain of a value. Now, because of how compute has scaled, and because of how abundant and standardized storage has become, you don't need to have a kind of knowledge base over there and a database over there and like an analytics store over here. All of that unifies onto one pane of glass. Okay. So that means that the idea of finance having a direct communication through the system to HR and being able to communicate back. And it's not just, communication like you and I are talking now. I can communicate, I can include data sets and empirical evidence that supports what I'm communicating in real time. If that is the new paradigm, because that is now the accessible way of building software and solutions, where everything can flow through the same thing and you don't actually need many, many different databases. Like effectively that becomes completely unified. It's a utility. Like I say, store this. I don't actually have to worry that it happens to be an image and it gets stored in a specific way and it gets indexed in a specific way and the insights get drawn in a specific way. That is immaterial to me. It's hidden. It's kind of sits, but it's still my asset because it's still in open format. If it happens to be this large, dense JSON file that comes out of like a bunch of sensors over there, or it happens to be, some communication data that comes out of your team's communication with someone, it all goes into the same place. It gets treated differently based on whether it's private, whether it's IP sensitive or other forms of tagging. But domain A, and I'm saying domain A instead of saying finance, because remember what I said, roles become soup. All right. So you might reorganize completely differently based on how work happens rather than how functions get sort of built. Because you no longer need to build solutions that are specific to a function. You can actually build them specific to the flow of the organization. It's going to take a fundamental step change in how we think about reorganizing. And again, domain-driven design thought this through, SOA thought this through, many different architecture paradigms thought this stuff through. It was just very unachievable. So that's the way people should be thinking, is that the unification of data is sort of happening. I mean, this idea of OLTP over there and OLAP over here and knowledge management over there and image management over there, it's redundant. It's completely no longer the way. So how would you build when those limitations and those silos disappear? Like would you build in a fundamentally different way? And that means that data engineers and application developers actually are now in the same team. Okay, what could they build if they're in the same team? What could they build if actually they worked for finance? So they weren't even in IT. I'm going to leave you with one really kind of profound thing. How big do you think the average digital natives IT department is in terms of headcount?
Real people or agentic people?
No, real people.
Maybe 1%.
2% of the headcount is the average digital native. That's a digital native. I'm not even talking about AI natives because we haven't figured those out yet. So like if you're a traditional enterprise and you have like 20% of your headcount is IT, like how would you recalibrate that for this type of change in the company? And it's a really hard problem to ask. So, but we have to answer it, right?
People are messy, but fantastic. Dael, I'm conscious we're over time, but as always, extraordinary value from you and extraordinary insights as always. Thank you so much for sharing again today and having joined us. I know that we will get numerous comments and numerous questions to have you back, and it would be our absolute honor to have you back here talking again on a DVT Insight session. I do hope that we will have that from you soon.
Cool. It was lovely to see you and really great to chat to everyone today. And yeah, obviously special place in my heart.
Fantastic. And to our audience, thank you for joining us today. If you're looking for more phenomenal and exciting speakers like Dael, do let us know. They are hard to come by, but we will certainly endeavor to have them here to speak to you, and most certainly endeavor to have Dael back to speak to you again. Thank you all for attending. Have a great day, and we look forward to seeing you in the near future.